Okay, hoping the sound is working. And now I'm going to share the screen. Hi, how are you doing? And can you hear my voice okay this time? Can you hear me? Can you hear me speak this time? Brilliant. Right, great. Okay, well, thanks for being early. I'm going to put the link for anybody who needs to download the questions here, and then I'm going to start in about 15 minutes, okay? Brilliant. Well, you should be in good form today then. That sounds great. Yeah, of course you can use a computer to write the answers. Absolutely. And can you just confirm for me that you can see my screen share, okay, with that welcome message on there? Brilliant. Thanks for letting me know. Tip-top tips. Yeah, I don't mind how you run through the questions. If you've done them already, everybody, you could have them on a piece of paper in front of you and work through them as I do. Or you can be working digitally on a screen. It's entirely up to you. Now, I wonder how many of you got mocks next week? Anybody got mocks next week? Let me know in the comments or hit the like button. Oh, hi Noah, how are you doing? Good to have you here. I'm hoping that you've downloaded the questions, Noah and everybody else. If you haven't, the link is at the top of the chat on a pinned comment. We'll just wait until 11:35 just to give everyone a chance to get themselves organised. If you're bored and waiting for me and you haven't made a start on the questions, then there's no reason why you shouldn't be working your way through question 1 and 2. I think question 1 is a simultaneous equation and question 2 is a more difficult question, I guess, involving indices. Well, that's great. You're very welcome to come to all of the lessons. Tomorrow, what do we got tomorrow? Tomorrow we've got grade 4, 5 and 6 questions. I think that's at 10:30 tomorrow. And from then on, anyone who wants to join every week, you'll need to send me an email and I'll send you details of my past paper club. And what we do every week is we do a past paper together online. We tend to start in February after mocks, and then we do a paper a week throughout the rest of this term and in the summer term before your exams too. Okay, we are T-5, so make sure you've got the questions. Make sure you've got the questions, and if you want to make a start on them, then do. Okay, well, there are 12 of us, but we're going to give it another couple of minutes just to give only latecomers a chance to join and for you to get ready. The link for the questions is at the top of the chat if you need that. With any luck, you've got the questions already. And with any luck, if you haven't already started the questions, you're starting them now so you can get a few minutes ahead of me. Those of you who are coming to the live tomorrow, you can download the questions for that from the same link. You can download the questions for tomorrow's live, which is questions grade 4, 5, and 6 questions. And if you're somebody who thinks, well, that'll be quite easy, well, that's fine. Obviously, you don't have to come. But if you're going for a grade 7, 8, you've got to get the 4, 5, and 6 questions right as well. So it might be worth downloading the questions and having a look through them and then deciding whether or not to come to the live. If you're somebody who's going for a grade 4, 5, or 6, and these grade 7 questions are tough for you, then definitely come to the live tomorrow, because then you can just make sure that you're okay on those easier questions before your mocks. Okay, we are going to start in a couple of minutes. We've only got 12 of you. Hit like a few times, please, if you would, or hit the heart button or whatever other buttons are available to you. If we can get some reactions going, then it might just prod some people to join. I'd much rather they join now than joining in 5 minutes time. Okay, right, well, we're going to make a start then, and we're going to start off with this question 1 here and this question on simultaneous equations. Now, both of these equations are linear, and you've got 2 methods you can solve these with. You might like to use this first equation to perhaps get an expression for x and then substitute that into the second equation. Or you might like to solve these two simultaneous equations by elimination. I'm going to solve them by elimination because elimination is easy to use even when you haven't got a single x or a single y in one of the equations. So I always do these the same way. I always get my coefficients on the x the same, and then I subtract the equations. So in this case, I'm going to multiply this top equation by 7, because that's going to give me 7x in that top equation, which is the same number of x's as I've got in the second equation. So now I've got my coefficients of x the same, and so I'm going to subtract the equations. Now, I always go minus, 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 and put those minus signs in, because it stops me not noticing if there's a double negative. You see, in this case, you're going to go 7x minus 7x, so you've got rid of the x's, that was the idea. But then you've got 7y minus minus 5y. So that is 12y equals 105 minus 3 is 102. So now I can divide both sides by 12. And of course, you've got a calculator if you want to use it. I would use it if I were you. And you get y is 8.5. So having done that, you need to substitute into one of the other equations, into equation 1 or equation 2 to find x. And I would definitely go into one of the original equations. Okay, so I'll pause for a minute and let you do that in case you haven't already. Now, if I was substituting, I think I'd probably substitute into equation 1, because let's face it, equation 1 is quite a straightforward equation. X plus y equals 15. And so I'm going to put 8.5 in instead of the y. So x plus 8.5 equals 15. So now if I subtract 8.5 from both sides, I get x is, what's that, 6.5. Now, because you're in year 11, most of you will probably decide not to bother to check in the second equation, but that would be the wrong thing to do, because sometimes in the mark scheme it gives a mark for the check. So I always check into the other equation, and what I do to check into the other equation is I just substitute that value of y, this 8.5, I substitute that into the second equation, just like I substituted it into the first equation, and I just check that I get the same answer for x. That's the way that I find it easiest to check. So on my calculator now, I'm doing 5 times 8.5, which gives me 42.5. And now I'm going to add 42.5 to both sides. Gives me 7x equals 45.5. And so now I'll divide both sides by 7. And lo and behold, I get x is 6.5. So then you're ready to write your answers in the answer space. And so I've got x equals 6.5 and y equals 8.5. Right, I'm just going to look across at the comments and see if anybody's asked a question there. Okay. Right, hi Rhythm. I hope that question 1 makes sense to everyone. In a couple of minutes, I'll work on question 2. But I'll give you a chance to have a look at that question and to be ahead of me on question 2. Nobody's mentioning in the chat that they've got a query on question 1, so that's good. Right, here come the answers for question 2, or I'm going to work through question 2 now. Right, where's it gone? Here it is. Right. Now, question 2. What they're asking you to do here is they're asking you to find the value of n. So essentially, they're asking you to take this right-hand side and change it into 2 to the power of something. And whatever that something is, That's what n is. So I've got 8 over 2 to the power of 7. And the trick is here is to realise that they want you to put that 8 in base 2. They want you to write that 8 as 2 to the power of something. Now 8 is 2 to the power of 3, 2 cubed. So this boils down to 2 to the power of 3 over 2 to the power of 7, which of course means 2 to the power of 3 divided by 2 to the power of 7. And now they're expecting you to remember your rules of indices. When you divide, you subtract the powers. So 2 to the power of 3 divided by 2 to the power of 7 is 2 to the power of 3 minus 7 is minus 4. So n is equal to minus 4. That is part A of question 2. So I'm going to look across the comments in case anyone's got any questions. Meanwhile, you can have a look at question B if you're happy with question A. What are you confused with, Noah? I'm assuming that you are okay with the fact that 8 is 2 to the power of 3, the whole thing. All right, well, let's have a look at let's move on and do part B. Okay. Now I'll show you the rule that you need for part B. Now, in part B, here you've got 13 to the power of minus 6 raised to the power of 4. Now it's really useful to know the rule there. Let's do it with an easier one. Let's do 5 squared raised to the power of 3. Well, that is 5 squared times 5 squared times 5 squared, which is 5 to the power of 6. Why have I written 6 to the power of 6? Which is 5 to the power of 6. So the rule here is if you've got an expression with a power and it's raised to another power, you multiply those two powers together. Look, 2 times 3 is 6. So I'm going to use that rule here. I've got 13 to the power of minus 6, and that's raised to the power of 4. So that is going to be 13 to the power of minus 6 times 4. 13 to the power of minus 24. And then I'm multiplying that in the question here by 13 to the power of 5. And so now, if I'm multiplying those two expressions, I'm going to add the powers. So that's going to give me 13 to the power of minus 24. Add 5 is minus 19. And so in this case, k equals minus 19. That's the answer to that one there. Right. So if anybody is finding that tricky, those rules of indices, then send me an email and I will send you a link to a film to remind you about the rules of indices. Okay. But in this case, you simplify the left-hand side and you work out the left-hand side all boils down to 13 to the power of minus 19. So k is minus 19. But do send me a message and I'll send you a useful link. Right. So I'll pause for a minute to give everyone the chance to crack on with the next question and to get a step ahead of me and have a look at that one before I do. Meanwhile, I'm looking at the comments in case anybody has anything to ask. Okay. Right, I'm going to move on to the next question now, hoping that you are ahead of me. Question 3. Now, in question 3, you will find it useful to know the formula for the volume of a sphere. And if you're doing the Edexcel IGCSE, this formula is given to you on the formula sheet. So I'll give it to you here. So the formula for the volume of a sphere is 4/3 pi r cubed. Okay. Now, in this case, we've got a solid metal sphere and it's got a radius of 1.5. The minute I see a question with loads of words, I end up underlining lots of stuff, so I don't have to read it again and again. The mass of the sphere is 109.6. Mass equals 109.6. And I'm asked to work out the density of the sphere. Well, how do I work out density? Well, density, this is my mass, density, volume triangle. Density is equal to mass divided by volume. Well, I know the mass because it's told me the mass in the question, but I don't know the volume. So the first thing I'm going to have to do is to work out the volume of the sphere. So the volume of the sphere, well, here's the formula, 4/3 times pi times r cubed, which is going to be 4/3 times pi times, the radius is 1.5, isn't it? 1.5 cubed. So that's how I'm going to work out the volume. And once I've worked out the volume, then I'll be able to work out the density. Now, if you put that in your calculator, you get 9/2 times pi. You could work out what that was, but I'm not going to bother. I'm just going to leave it as 9/2 times pi. And now I'm going to work out the density. Well, the density is the mass, 109.6, over the volume, which is 9/2 pi. Now, if you're doing that in your calculator, if I were you, I'd do 109.6 divided by, and then open a bracket and write 9/2 times pi, or 9/2 pi, and then close the bracket to make sure that your calculator understands that you're dividing by the whole of that expression. Now, if you put that in your calculator and you put the answer to 3 significant figures, which is what it asks for, then I hope you get the answer 7.75. At least that's what I get. So that is my solution to number 3. Now, nobody's talking to me in the chat, so I'm hoping that means that you're all happy with that. If you've got a question, then by all means, ask me in the chat. If you are happy with that one, then move on to number 4. If you want me to slow down, tell me in the chat. Okay. And in a couple of minutes, I'll move on to number 4. Hit like if you're ready for me to move on, and then I can move on without worrying that I'm going too quick. Okay, right. See what's coming up next. Oh, look, it's another advert for Past Paper Club. I've got 3 more places left. I've got Saturday morning is full, and I've got 3 more places left on Monday evening. So if you want to know more, send me an email and I'll tell you all about it. Right, question 4 is coming up. Oh, look, I'll just leave my email address on there in case you want to write it down. Mr. Wright at mrwright@igcsemaths.com. Okay, question 4 now. In question 4, I've got a hexagon, and it even says the diagram shows a hexagon. So before I read the rest of the question, I'm thinking, what do I know about a hexagon? What do you know about a hexagon? Well, we know it's got 6 sides. Do you know the total of all the angles in a hexagon? The angle total. You should know how to work out the angle total of a polygon. Okay, what you do is you do the number of sides, 6 minus 2, and then you multiply that by 180. That's the formula for the total number of degrees in any polygon. The number of sides minus 2 times by 180. Now that formula isn't given to you on the formula sheet. So that's one of the formulas you need to remember. The total number of degrees in a polygon is n minus 2 times 180. Now in this case, that's going to be 4 times 180, which equals 720. By the way, I haven't really read the question yet, but I'm just thinking, what do I know about a hexagon? Okay. If it was a regular hexagon, we could work out the exterior angle as well, couldn't we? But that isn't a regular hexagon. But I do know that all the exterior angles would have to add to 180. Now, let's read the question. The diagram shows a hexagon. Yes, it does. Oh, BC is parallel to ED. Okay. Work out the size of the obtuse angle DEF. That's this angle here. That angle there is the one we're trying to work out. Well, that's one of the angles inside the hexagon, isn't it? I know what all the angles of a hexagon add up to. They all add up to 720. So if I know the other 5 angles, I could do 720 minus the other 5 angles, and that would tell me the size of the 6th angle, wouldn't it? The size of the angle I don't know, this angle here. But the trouble is I don't know the other 5 angles. I do know 4 of them. I know this one, this one, this one, and this one. But what I don't know is this one here, the angle at D. But can I work it out? If you're able to use those parallel lines to work out the angle at D, then you can go ahead and work out the size of the angle at E, which is what the question is asking you for. So the question is, how do I work out the size of that blue angle there? Right. Okay. So the size of that blue angle. Anybody got it? I'm looking at the chat at the minute. Anybody got the size of that blue angle? Anybody know how to do it? We haven't used the parallel line fact yet, so I'm going to draw out those parallel lines and see if I can make some sense of it. So what we've got is we've got the parallel line here from D to E, right? Sorry, from E to D. And then we've got the parallel line from B to C, right? Let's draw them too long, shall we? So those are my 2 parallel lines. And let's say that this is point D here. So here's the line that goes from D to C, right? There's point C there. And I know that that one's 42. And I want to find this angle here. Any ideas now? Well, there are lots of different ways of doing that. Okay. One of the ways of doing it is to say, well, if that's 42, then that angle is 138 because of 180 on a straight line. And that angle correspond. So my missing angle is 138. Another way to do it is to realize that these 2 angles are inside the parallel lines. So they add up to 180. There are lots of different ways of doing it, but the trick is to draw out those parallel lines so you can see the bigger picture. So that missing angle at D is 138. And now you're in a position to do 720 minus the 5 angles of the hexagon, which leaves you, of course, with a value for the 6th angle, for the angle at D. Okay. So nobody's shouting at me in the chat, so I imagine that you're okay with why that's 138. And all you've got to do now is to work out on your calculator what the missing angle is. Give me an answer in the chat. Give me a like if you're ready to move on. And make a start on question 4. Sorry, question 5. Okay. Yes, 250 now. I agree with you. So if you've got 250, then you can hit like, move on to question 5, and I'll chase you. I'll be a step or two behind you. $292, Melody. How did you get 292, I wonder? I got 250. I'm wondering, I suspect you didn't subtract away the 42. Okay, I think that you've just done 720 minus 50 minus 96 minus 144 minus 138, and you've omitted to subtract the 42. I hope that makes sense to you, Melody. But I've got no way of reading your mind, so you'll have to tell me in the chat if you're happy with that. Oh, is a message retracted? Is that, yes, I understand it now. Okay. I'm going to move on to question 5 in a minute or two. If you're ahead of me, all well and good. All right, question 5. All right, so cumulative frequency graph. The cumulative frequency graph shows information about the length in minutes of each of 80 films. Now, when you do these questions in your exam, it's really tempting not really to read any of this stuff. You just end up looking straight at the diagram. That's the wrong thing to do. Okay, what you need to do is you need to read the question and underline stuff. Look, of each of 80 films. We might find that useful in a moment or two. Okay. All right. Use the graph to find an estimate for the interquartile range. Right. Well, when I do the interquartile range, I generally, first of all, mark off the median. Okay, now the median is going to be the halfway one. Now I've got 80 of them. So I draw my line to find the median. I draw at 40 here. Now it'll be easier for you with a pencil and a ruler than it is with me on the screen, but that will tell me the median, and the median is going to be whatever that is. I mean, we're not asked for the median, but it's about 111, isn't it? Okay, that's the median. Now, how do I find the interquartile range? Well, you know how the median has split the 80 in half? That's the first 40, and this is the second 40, right? So the median cuts the 80, what are they, films? What are they? The 80 films in half. 40 over there, 40 over there. Right, now, to find the interquartile range, what you do is you split the 80 films into quarters. So if we've got 40 here, I'm going to split it at 20, look. So I split the first half into half, and now I'm going to split the second half into half, right? The second half is this lot. And so if I split them into half, then I'm going to be looking at the 60th film. And so to find the interquartile range, you find the range, the difference between the 60th, I'll use a ruler, the length of the 60th, which is, what is that, 123, right? So the length of the 60th is 123, because that's the third quartile. It's the length of the film that's 3/4 of the way through the 80. And now I'm going to find the length of the 20th as well. Okay, so the length of the 20th, look at that, it's 103, I think. So the 20th is 103. So the interquartile range here, I reckon, is 20. 123 minus 103. Now you see, if you were asked for the range, you would find the difference between the length of the longest film, which is 140, and the length of the shortest film, which is 80. So the range is the difference between the shortest and the longest, whereas the interquartile range is the difference between those two there. So it doesn't take, it knocks out the extremes. It knocks out the very shortest of the films and the very longest of the films, and it just finds the distance or the difference between that one and that one, rather than between the longest and the shortest. That's the interquartile range. Okay, I'm just going to have a quick look at the comments in case anyone's got anything to do. Okay, so Melody's happy and nobody's asked a question about this interquartile range question, so I'm hoping you're okay with that. Right. Okay. Claire says, more than 35% of these films are over 120 minutes long. Is she correct? Well, let's work out what percentage of the films are over 120 minutes long. So, well, I wonder how many of the films are over 120 minutes long. Let's have a look. Right, I'm going to use a green here. Here is 120 minutes, right? So let's see how many of the films are over 120 minutes long. I'm going up to here, and now I'm going across to here. And I can read off there, that's 55, right? Now that means that 55 of the films are less than 120 minutes long, or 120 minutes long or less, right? So less than 120 minutes is 55 films. Okay? So how many films are more than 120 minutes long then? Well, there were 80 films altogether, weren't there? So therefore, what's that going to be? 25 films are over 120 minutes, right? Over 120 minutes, 25 films. Now, what is it that this person says? More than 35% of the films. Well, I don't know. What percentage is that? 25. What percent is that of 80? 25 over 80 times by 100. Right. 25 divided by 80 equals times by 100 equals, well, actually, 31.25% of the films are over 120 minutes long. And what she said? 35%. Well, she's wrong, isn't she? Okay. So there are two things, well, several things to understand here. First of all, are you happy that 55 of the 80 films are less than 120 minutes long? So 25 of the 80 films are over 120 minutes. So that is 31% of the films are over 120 minutes. So now we need to answer this question. More than 35% of the films are over 120 minutes long. Is she correct? Now look, this question here, it needs a yes or a no. Okay? So you need to say no. You need to write yes or no, because that's the question. Is she correct? It needs a yes or a no. Give a reason for your answer. Well, all my working would be my reason, wouldn't it? And I could say here 31.25% of the films are over 120 minutes long. Okay, so that is that question done. So that's all of question number 5 on the screen for you there. If you're happy with that, hit like and move on to question 6. If you've got a question about question 5, then stick it in the comments and I'll try and help you out. Okay. Hoping you're ahead of me. Okay. Nobody's shouting at me in the comments. Hit like if you're ready for me to move on, please. Or if you've moved on, hit like. And in a minute or two, I will make a start on question 6, which is about bounds, I think. You're not very keen on hitting like. If I said 65% is 118, therefore 35% is... Yeah, I think that's absolutely fine. Top tips, cool name. I think that's absolutely fine. As long as the examiner can see that you're working out, using the graph to work out how many films are over, and then you can say, you know, yes, it's wrong. That's fine. Okay. They just want to see you using the graph to work out how many films are over 120 minutes, and then they want to see you comparing that with what Claire has said. All right. Okay, we're on bounds now. So with any luck, you're on the bounds question. I'm going to be quiet for a minute, give you a chance to keep one step ahead of me. Okay, right. I'm going to keep us moving, or I'm going to keep moving. Oh my lord, look at that! Another mention of Past Paper Club. Nobody's emailed me yet, so send me a message if you want to know anything about Past Paper Club. The bottom line is that however hard you've worked at your maths, or haven't worked at your maths over the last few years, your grade is going to depend solely on your marks on the papers. So one way or another, you've got to get lots of past papers under your belt. So if you've got a way of doing that already, then that's great. But if you haven't, send me an email and I can tell you how I can help you out. Right. Oh, here's the bounds question, number 6. Okay. Now, the minute I see it's a bounds question, then I straight away know what I've got to do. And I straight away know that I've got to write down the upper and the lower bound for my variables. In this case, we've got E, which is 8.31. So I always write that down and then I do that. And we've also got F, which is 0.65. So I write that down and then I do that. Now listen, if I get one of these wrong, right, it doesn't really matter, because as long as I lay out this bit here, then the examiner will see what I've done wrong and I'll still get the credit for my methods as long as I choose the correct upper or lower bound for E and the upper or lower bound for F. Okay, where people lose more marks than they should is when they don't write that bit and they just dive straight into working this out. And they do the bounds in their heads. And then if they've made a mistake with their bounds, all the examiner sees is a wrong answer. The examiner can't see that they've just made a mistake in working out their upper and lower bounds. So they don't get any credit for the question when they should get credit for the question. So always do this bit. Also, it makes you think about it as well. 8.31, right, the upper bound is 8.315. And the lower bound is 8.305. Now, I'll pause for a moment. You can write down the upper and the lower bounds of F if you haven't already. Upper bound of F, 0.655, and the lower bound, 0.645. Right, now, it wants the lower bound of E minus F. So now I need to have a think. If I want the lower bound of E minus F, which do I want for E, upper or lower, and which do I want for F, upper or lower? Well, I want the difference between these two to be as small as possible. So I'm going to take the smallest possible E and the highest possible F, because then the difference between E and F is as small as it can be. And so only now do I write 8.305 minus 0.655, and then I can stick that in my calculator and work out the answer. 8.305 minus 6.55, sorry, 0.655, and I get the answer 7.65. Okay, now can I just labour this point, please? You must, if you want to be sure of getting all the marks you deserve, you must write that bit, you must write this bit, and you must write this bit where you work out and show the examiner that you're working out whether you're going to use the upper or the lower bound of each of your variables. Okay, right. Nobody's shouting at me in the comments, so I hope that means that you're happy with question 6. Okay. If you're happy with question 6, hit like, hit something, tell me in the chat, do something, so I know I can move on in a few minutes, and move on ahead of me and have a look at question 7. We've only got 7, 8, 9, 10, 11, and then we're done. Right. Okay, I'm going to move on, I think. I've got one thumbs up from Melody Maven, and somebody's just hit the like button, so I'm assuming that I can move on now. Okay, it's much easier on Zoom than it is YouTube Live, because then at least you can speak. But I suppose there's a joy to me just hearing my own voice. Oh my lord, there's a mention of Past Paper Club. Right, move on. Right, now. Question 7 coming up. Right. Now, in 7a, I'm afraid to say that when it comes to your exams, with any luck, you will be able to simply know what anything to the power 0 is. Anything to the power 0 is equal to 1. That's just the way it is. Don't even think about it. Okay, now I've got 2 different ways for you for 7b. Now, I used to do it like this. I used to say 3x squared y to the power of 5 cubed, and I used to make myself say, right, what does that mean? It means something cubed. So it means the something times the something times the something, right? And then I used to write that that's 3 times 3 times 3 times x squared times x squared times x squared times y to the 5 times y to the 5 times y to the 5. And then I would go 3 times 3 times 3 on my calculator. which is 27. X squared times x squared times x squared, add the indices, x to the 6. Y to the 5 times y to the 5 times y to the 5, add the indices. That's what I used to do. And there's nothing wrong with that. And if that works for you, then please do it. Okay? But there is a quicker way. And I know because it's quicker, suddenly everybody thinks it's better. It's not better. Okay? But you remember how before we had this, I can't remember what the example was, but it was something like a to the power of 5 raised to the power 6, and we multiplied those powers. So that would be a to the power of 30. All right? Well, you can use that rule here. So you've got 3, I'll do it in a different colour. You've got 3x squared y to the 5 to the power of 3. So that's going to be the 3 first is the power 3. That's okay, I can manage that. And then the x squared is being raised to the power of 3. So multiply those together. That gives you x to the 6. And the y to the 5 is being raised to the power of 3. So that gives you y to the power of 15. And then you can just work out the 3 cubed is 27. So you can do it in that quicker way if you want to. But to be honest, it's not about doing it quickly. It's about doing it whichever way means you're going to get the answer correct, because you've got loads of time in your exam. So it's not a rush, it's not a race. You just do it in the way that works for you. All right? Okay. Right, I'm moving on to question C now. Nobody in the comments is telling me to slow down, so I'm going to carry on with question C. I've got 2e squared minus 18. And I'm going to factorize it. So I'm going to pull out any common factors. Okay, just checking the comments in case somebody said, will you wait a minute? But nobody has. Okay, so I'm looking for common factors. Right, the first thing I can spot is that 2 goes into both of these expressions. So I can put 2 outside the bracket, and I've got 2e squared minus 9. Good. Now, do you see how it says factorize fully? Well, that's a bit of a hint that maybe it's not as easy as you think, because this can be factorized further. You see, this bracket here can be factorized into 2 brackets. Okay, with an E and an E. Now, I'm kind of going slow so you can get ahead of me, really, or you can be thinking too. Got to have a number here and a number here, right? The 2 numbers have to multiply to minus 9. Well, they multiply to a minus, so one of them's a plus and one of them's a minus. They multiply to 9, but there are no e's, are there? This is like e squared plus 0e minus 9. There are no e's, so they have to multiply to 9 and add to 0. So it's plus 3 and minus 3. And that is the answer to this. Okay? All right. Okay, I'm just going to look at the comments before I do part D in case anybody's got anything to ask. Okay, well, top tips, you seem to be asking about an entirely different topic, which is fine. You do the first, well, they should both boil down to the same thing, both of your suggestions there. But if you send me an email, top tips, then I will send you a film, I'll send you a link to a film that tells you what to do. Okay? All right. Okay, now I'm going back now to make R the subject of this. Okay. Right. I've got M equals the square root of 6a plus R over 5R. And I've got to make R the subject. The first thing I'm going to do is get rid of that square root. I'm going to square both sides. So I'm going to have M squared equals 6a plus R over 5R. Okay. Next, let's multiply both sides by 5R to get this off the bottom, right? If I multiply both sides by 5R, then I'm going to have 5R times M squared equals 6a plus R. Right. Now I want to make R the subject. So I'm going to put everything within R in it on one side and all the other rubbish on the other. So I'm going to subtract an R from both sides. So I'm going to have on the left now 5rm squared minus R equals 6a. Okay, right. Now we're going to stare at that for a minute and we're going to think, how do I make that into an R equals? Now, what I say here is that you have to factorize and divide. I've got a colleague who would just say, look, everyone, you just have to F it to factorize it. Okay? Another way of thinking about it is that you've got two R's here, and you have to do something to make those two R's become one. It's like a love story. Make the two R's become one. What you do is you put the R outside the bracket, and then you have 5m squared minus 1. And look at that. I had two R's on the left-hand side, and now I've got 1. So two R's have become 1 equals 6a. Okay, and now I can divide both sides by that bracket. So it's R equals 6a over 5m squared minus 1. So what I did here is I factorized and divided, or I F'd it, or I made the two R's become 1. You remember it however you need to, but that comes up very often. And again, if you want a practice film on rearranging, send me an email and I will send you a link. Okay. Right. I'm going to pause. I'm looking at the comments. Nobody's said anything, I don't think. Ask me a question if you want to. Hit the like button and move on if you're ready to. On to question 8. Question 8's tricky. Okay, have a go at question 8. If you get stuck on question 8, move on to question 9, and I'll give you a few minutes to do some work to get ahead. Okay. All right. Okay. Right, Frion, I'm not quite sure what you mean by exam paper 8. If anybody wants to do any work between now and tomorrow's live, then the thing to do is to work your way through the grade 4, 5 and 6 questions, which you can download, which are the questions that I'm doing tomorrow. Okay, I'm going to move on to look at number 8. Now, can I suggest that if you are working on your own through number 9 or 10, that you stop and you pay some attention to number 8, because this is trickier than it looks. Now, it says that the table below gives some information about the number of mice in some nests. Okay, you can see, now take a moment, understand the table. It says number of mice 5, frequency 4. Ask yourself what that means. That means that there are 4 nests with 5 mice in each nest. Okay, and there are 13 nests which have got 6 mice in each nest. So let's just take a minute, understand what the table means. Now it tells me here the mean number of mice in a nest is 7. Now let's just stop a moment and let's assume that you knew what this x was. Let's just make it 10 for the sake of it. And let's just imagine that it said, here's some information about the number of mice in a whole load of nests. Work out the mean number of mice in a nest. Well, what would you do if that was the question? Would you simply work out the average of this yellow column? And no, you wouldn't. Would you work out the average of this column? That's the number of mice in each of the different nests of different sizes. No, you wouldn't. What you'd have to do if you were working out the mean here is you'd work out the total number of mice and you'd divide by the number of nests, because you'd work out the number of mice per nest. Okay? How would you work out the total number of mice? Well, what you do is you do 5 times 4, because those 4 nests each have 5 mice, so they have 20 mice. Then you do 13 times 6. Crikey, what is that? 60, 78. Then you do 7 times 16. What is that? 70. Is it 112? I think so. Then you do 8 times 10. Remember, it's just a made-up one for now. 80. And then you do 6 times 9, 54. You'd add those up, and that would give you the total number of mice. And then what would you divide by? The number of nests. How many nests are there? That's the number of nests, the total of the frequency column, right? So in this case, it would be whatever they are up to. Okay, I'll put a triangle there. That would be that total there. Okay, that's how you'd work out the mean if you're being asked to work out the mean. Now, that's not what we're being asked to do. We have got to work out the value of x, but they do tell us that the mean number of mice in a nest is 7. So that means that the total of all the mice, the total number of mice divided by the number of nests is equal to 7. And this is going to help us set up an equation. Now, what is the total number of mice? Well, it's still 5 times 4. It's still 6 times 13. It's still 7 times 16. 8 times x. Oh, that's 8x. And it's still 9 times 6. So the total number of mice in the nests is the total of all of that lot, right? So if I do 20 plus 78 plus 112 plus 54 on my calculator, I get 264. So the total of all the mice here is 264 plus 8x. So that is the total number of mice, 264 plus 8x. And how many nests are there altogether? Well, there is 4 plus 13 plus 16 plus x plus 6. Well, if I add all that lot up, I get 39 plus x. So I know that the total number of mice divided by the number of nests equals 7. And so this is the equation. This is the equation here, which I have to solve. Okay? And once you've set up that equation, then you can get on and solve it. But lots of people find the difficult bit is setting up that equation to start with. Right, if you're okay with that, then you can get on and solve it. I'm just going to look in the comments. What's the difference between paper 1 and paper 2, Dylan? There isn't a difference. Okay, any topic could come up in paper 1 and any topic could come up in paper 2. But generally, when you've done paper 1, you can see what topics have already come up, and then you can have an educated guess at what topics will come up in the second paper. Okay, right. So we're going to solve this equation now. I'm going to multiply both sides by 39 plus x, because that's on the bottom. So I get 264 plus 8x equals 7 times 39 plus x. Okay, well, I can multiply out that bracket on the right now. 264 plus 8x equals 7 times 39. Work that out on a calculator. 273 plus 7x. Now, this is an equation with unknowns on both sides. So I'm going to subtract 7x from both sides. So I've got 264 plus an x equals 273. And now I'm going to subtract 264 from both sides to give me x equals 9. So you see, the trouble is, that's quite a complicated question, really. No wonder it's grade 7, because of setting up that equation at the start. Okay, I'm going to leave that on the screen for a minute or two. Ask me a question in the comments if you'd like to, or if you're ready, hit like and move on to question number 9. We've only got 9, 10, 11 to go, so well done, folks. We're doing okay. Nobody's asked me a question about number 8, so I'm hoping you've moved on to number 9. Hit like if you're ready for me to move on. I mean, I've got 11 whole likes. Okay, right, I'm going to move on. Okay, I'm sure that we don't want to take, I'm sure you've got other things to do, other things to move on to. So I'm going to move on to number 9 now. Okay. Marcus plays 2 games of tennis. For each game, I'm going to underline this again, the probability that Marcus wins is 0.35. Complete the probability tree diagram. Oh, so the probability he wins, look, is 0.35. So if I do 1 minus 0.35, then I get the probability he loses. Oh, sorry, he does not win. Okay. So that's going to be 0.65. Right, now let's imagine that he wins his first game. So now we're over here. Right, probability he wins the second game. Well, we know the probability he wins is 0.35, isn't it? 0.35, so the probability he loses 0.65. And in the same way, I'm going to write 0.35 here and 0.65 here for the probability of him winning or not winning his second game after he loses the first. So that is the probability tree diagram complete, and that's 2 marks. Well, that wasn't very difficult. Number 9, work out the probability that Marcus wins at least one of the 2 games. Well, let's just have a look at each of these outcomes, shall we? Look at this. Marcus wins, Marcus wins. Well, that's a win-win. Next one is Marcus wins, Marcus loses. Sorry, does not win. I'm going to call it losing. So win followed by losing. Next one. Marcus loses, Marcus wins. Lose, win. Next one. Marcus loses, Marcus loses. Lose, lose. Right. Work out the probability that Marcus wins at least one of the games. Well, he wins at least one here. He wins at least one here, and he wins at least one here. He doesn't win at least one here. So I've got two ways of doing this. I could work out the probability of lose-lose and take that away from 1, because that will give me the total of all of those. Or I can work out the total of this one, the total of this one, and the total of that one. Sorry, the probability of this one, the probability of this one, and the probability of this one, and then add those 3 probabilities together. I'm going to do the first way because it seems shorter. So the probability of lose-lose, remember, you multiply as you go down the tree. So that's going to be 0.65 times 0.65. So that is 0.65 times 0.65, 0.4225. So the probability that I'm looking for is 1 minus 0.4225. which is 0.5775. And that's the same answer you'd have got if you'd worked out the probability of win-win, win-lose, and lose-win, and added those 3 probabilities together. Okay, so I'm leaving that on the screen for a minute. And I'm hoping that you're happy with that, and that you're going to move on to question 10. Hit like if you're happy for me to move on, or tell me in the comments. I'm going to pause for a minute or 2. Now, I'd hate to think, those of you who've got mocks coming up, that this is your only revision. So if you are revising a particular topic and you want some resources with it for it, then you can find them on my YouTube channel, or send me an email, or leave me a comment on a YouTube film telling me what you want resources for or practice for, and I'll send you a few links. The best thing you can do is, if you know how to do a topic, is then to practice a whole load of exam questions on it. And so if you send me what topics you're working on, then I can send you films where I go through a whole load of exam questions, and then you can just practice and work alongside me, and then you'll be sorted for your mocks. Right, I am moving on to question 10. Okay. Look at this. I think we might be using the formula here. So whoever it was who was asking about using the formula, maybe we'll be able to answer your question when we do this question. Now, this is a really good question because it illustrates a really good point. So, if you get a question like this, do you see how the first half says show that something is true? And then the second half says find the value of x. Well, please notice that you can do the second half even if you can't do the first half. Because in the first half, they tell you this equation, right? So when it says find the value of x, there's no reason why you couldn't just go ahead and solve that equation when you're doing part B. So everyone can get the marks for part B, even if they haven't got a clue how to do part A, okay? So sometimes, well, quite often, if you can't do the first part of a question, it's well worth looking at the second part, because this is a prime example where the second part everyone can do, regardless of whether or not they could do the first part. Okay, but of course what we want is we want everyone to be able to do the first part, so I'm going to go through that now. Okay, the diagram shows a trapezium. Right, what am I thinking about a trapezium? Straight away I'm thinking that I know how to find the area of a trapezium. To find the area of a trapezium, here's a trapezium here, To find the area of a trapezium, let's say that that is 10 and that is 16, and let's say that that's 6. You remember you do 10 plus 16 divided by 2. You find the average length, 10 plus 16 divided by 2, and then you multiply that by the height. Okay? So I'm straight away thinking I know how to find the area of a trapezium. The average of the parallel lengths times by the height. The diagram shows a trapezium. Oh, look, I've got the top length, I've got the bottom length, I've got the height. All measurements shown on the diagram are in centimetres. Oh, look, it tells me the area of the trapezium. So this is going to be setting up an equation, isn't it? Show that that's true, right? Well, let's get an expression for the area of the trapezium, shall we? The area of the trapezium, do you see I've got 10 here? So that's going to be x plus 5. Plus the 16, that's going to be plus 3x minus 2, divided by 2. Times the height, times the 6 in my example there, so times 2x plus 3. And that equals 133. So where it says show that this is true, I'm going to need to take this and simplify it and hope that I end up with the equation that they want me to have found. Okay? So let's do that one step at a time. Let's simplify this equation here. Well, the top of this, I'm looking at this bit here. X plus 5 plus 3x minus 2. Well, that is 4x plus 3 over 2 times by 2x minus 3 equals 133. Okay, so far, I hope. Now, what shall I do next? I was beginning to wish I'd written it more neatly now. What shall I do next? Well, I'm going to get rid of this 2 on the bottom by doubling the left and doubling the right. So I'm going to get 4x plus 3 multiplied by 2x minus 3 equals 266. I've doubled the left and I've doubled the right. You might be thinking, why hasn't he doubled the 2x minus 3? Well, this expression on the right is all one thing, isn't it? So if you double it, you just get rid of that 2 on the bottom. Right, I'm going to continue now, and I'm going to expand those 2 brackets on the left-hand side. Okay, so 4x times 2x is 8x squared. Now, I don't know how you like to do these. Okay, so I'm going to go 4x times 2x. Now I'm going to go the 4x times the minus 3, so that's minus 12x. Now I'm going to go plus 3 times 2x is plus 6x. Plus 3 times minus 3 is minus 9, and that equals 266. So now I'm going to tidy up the left-hand side. 8x squared minus 6x, careful, because it's minus 12x plus 6x, minus 9 equals 266. What am I aiming for? I'm aiming for this, look. It's got a 0 on the right-hand side, so let's minus 266 from both sides. And if you do that, then you can congratulate yourself because you end up with what they asked you to end up with. 8x squared minus 6x minus 275 equals 0. And that is how you answer part A, showing that 8x squared minus 6x minus 275 has to equal 0. I started with what they told me about the area of the shape, and I simplified it and ended up with the equation that they wanted me to end up with. So that's part A. And now part B. Find the value of x. So what this is asking me to do is it's asking me to solve this equation. 8x squared minus 6x minus 275 equals 0. Right, everybody. Use the formula, and I'll write down the formula here because you're given it on the exam in the formula sheet. So here comes the formula. It's x equals minus b plus or minus the square root of b squared minus 4ac all over 2a. Now just don't mess it up, okay? b squared minus 4ac all over 2a. There's a lot that's tricky on these papers. We don't want to be messing up the stuff that we can do. I'll be quiet for a minute while you have a go at using the formula. Now, who was it who asked about using the formula? Top tips. If you're still here, we're about to use the formula. Okay. Are you still here, top tips? Yeah, well, that's somebody hit the heart, so I guess that's top tips. All right. Oh, hello. Right. Okay, so because I am going to make very sure that I get this right, I'm going to write A equals 8, B equals minus 6, C equals minus 275. Now I'm going to write X equals, now minus B, well minus 6 is just 6, plus or minus the square root of, right. Let's open a big bracket. Right, I hope you're watching top tips. Now, be careful, because B is minus 6. So B squared, look, is minus 6 squared in a bracket. Don't write this. I'll write this in red. Don't do this. Minus 6 squared, because if you put that in your calculator, you're going to get minus 36. Whereas, if you put this in your calculator, you're going to get 36, which would be correct because it's minus 6 times minus 6. You get a positive. So just stick it in a bracket, that minus 6. Okay? Now, minus 4 times A times C. Okay? Close the big bracket. And that is all over. Twice A is twice 8, 16. Okay, so that is the, where's it gone? That is the expression that I've got there. So have a careful look at that, compare it to what you've got. Now, as long as you write that down, then you could just put that straight in the calculator if you wanted to. Okay, but make sure if you're putting it in the calculator, start by hitting that fraction button because it's one big fraction, isn't it? And then perhaps start by using the plus and then stick it all in, press equals, and then go back to it and edit that plus to the minus to get your second solution. Okay? Right, I'm just looking at the comments in case anybody's shouting. Nobody's shouting. Okay. Now, if I put that into my calculator, and it actually works out to 6 plus or minus the square root of 8836 over 16, which happens to be 6 plus or minus, and the square root of 8836 is 94, as it happens. So I haven't quite done what I've said. I've worked out several stages on the way. And then that gives me two answers. Right. The first answer is 6 plus 94, 100 over 16. And the second answer is 6 minus 94, which is minus 88 over 16. So those both boil down to 6 1/4 or minus 5 1/2. Okay. So it said I should find x. So I've got my equation there and I've solved it. Okay. I haven't actually finished because there's a trap here. Okay, because it says here, find the value of x. And do you see how it's a singular? It says find the value of x. But I've got two answers. So, well, of course I've got two answers. I've been solving a quadratic. So, of course it has two answers. But why does x only have one value? Well, to understand that and to get all your 3 marks for this question, you have to realise that there's no way that x can be negative, because x is a length here, isn't it? X has to go into these expressions here for the trapezium for the length. And if x is minus 5.5, then some of those lengths will end up being negative numbers. Well, that's no good. You can't have a negative length. So this minus 5.5 there, that is invalid. And the answer is that x equals 6.25. Okay? And I'm afraid to say you'd lose a mark if you left it as 2 possible answers. You'd lose a mark for that. You get full marks for that. Okay. Right, we've got one more question to go, and then we can call it quits. Nobody's asked me a question in the comments about that one. So I'm assuming that all is well. And I'm assuming that we're moving on to number 11. Okay, thank you for hitting the heart, whoever just has. Do we get a formula for question 11? What's question 11 about? No, I don't think you do. Let me have a look now at question 11. The diagram shows 2 mathematically similar vases. No, you don't get any formulas at all for number 11. This is about similar shapes, and it's about knowing the relationship between the different scale factors, the linear scale factor, the area scale factor, and the volume scale factor. I'll give you a hint. What I tend to do is I tend to go small, large, like that, and then I do linear, area, and volume, and then I fill in what I know. Okay, and then I can work out some scale factors. So I would do a table like that and fill in what you know and take it from there. Maybe that'll jog your memory. Okay, now after this question, no doubt you're all going to run away. So just a final plug. If you want to know about Past Paper Club, then send me an email and I can let you know how that works. It starts in February after mocks, and we do a paper every week. And then after the session, you get a recording of the session. You get my work solutions as well, and you get the mark scheme. Okay, so basically it means that every week you do a practice paper. But you might already have that. You might already be doing that at school as it is, in which case you're in good hands. So if you want to know about that, send me a message. If you are revising any particular topic and you want some resources on that topic, then send me a message too, and I'll send you a link or 2 to some useful films. Right, I'm going to do this question now. So it says, the diagram shows 2 mathematically similar vases, A and B. A is the small one, look, and B is the large one. A has a volume of 405. Okay, I'm going to write 405 here. B has a volume of 960. Okay, I'm going to write 960 there. Oh, wait a minute. I can work out the volume scale factor, can't I? If I do 960 divided by 405, then I'll know the volume scale factor. So the volume scale factor is 64 over 27, right? So to work out the volume of the large one from the volume of the small, I multiply by 16, 64 over 27. Okay. Wait a minute. If I know the volume scale factor, I can cube root that to get the linear scale factor, because the linear scale factor is the cube root of the volume scale factor. So I've got 64 divided by 27, 64 over 27 on my calculator, and I'm going to cube root that. Okay, 64 over 27, which gives me 4 over 3. So the linear scale factor is 4 over 3. And if I know the linear scale factor, then I can work out the area scale factor. I just take the 4 over 3 and I square it. So it's going to be 16 over 9. So I've used what I know about the relationship between these scale factors here. If you want a film on this, send me an email and I will send you a film all about this. Now I carry on reading the question, shall I? It says A has a volume, B has a volume. Oh, B has a surface area of 928. So 928 goes here. Work out the surface area of A. So it wants to know the surface area of A. Well, look, I know that the surface area of A multiplied by 16 over 9, because that's the area scale factor, equals 928. So I can work out this number here by doing 928 divided by 16 over 9. So you can just do that on your calculator. 928 divided by, because I'm going backwards, aren't I? 16 over 9. Right, 928 divided by 16 over 9 gives me an answer of 522 square centimetres. And that is your answer to question 11. Okay, and that is the end of a technologically faultless YouTube Live, which is a lot better than yesterday's. And if you want to come tomorrow, then you're very welcome. 10:30 tomorrow, we're doing some easier questions, grades 4, 5 and 6. So do by all means come tomorrow if you want to. You know where to download those questions from, I hope. So if you don't, send me an email and I'll send you the link. And have a good rest of the day today. Let me know if I can help. And I hope I'll see you tomorrow. Okay, I'm going to stop the sharing. Okay, and I'm going to say thank you very much for coming. See you tomorrow. Send me a message if I can give you a hand with anything. Okay, see you all later. Bye for now.